Good morning everyone and welcome back again. I'm Miss Daddy and this is Science Equals Fun. In the previous video we talked about matter and we said that matter is anything around us that has mass and volume. And we said that if we want to differentiate between different matters, we need to use physical properties or chemical properties. We can say properties or characteristics. We said that physical characteristics or physical properties like color, taste and smell, density, melting point, boiling point, hardness, electric conductivity and thermal conductivity. Chemical characteristics like very active materials, less active materials and inactive materials. In the previous video we talked about color, taste and smell and density. This time we're gonna talk about melting point. We already know that we have three states of matter: solid, liquid, and gas. Okay, how can we change a matter from a solid state into liquid state or from a liquid state into gas state? In this lesson, we'll learn how to change matter from solid state into liquid state. This process is called melting. And the temperature at which a matter changes from solid state into liquid state is called melting point. Melting process. What the meaning of melting process? It is the change of matter from solid state into liquid state. By what? By heating. So we need heat to change a matter from solid state into liquid state. Melting point, it is the temperature at which matter begins to change from a solid state into liquid one. Different solids have different melting points. We have two types. Substances have low melting point, like wax, butter, or ice. Substances have high melting point, like iron, copper, aluminum or aluminium, and table salt. I hear native speakers say aluminum or aluminium. We can say both. Aluminum, aluminium, the same thing. So we have substances have low melting point, wax, butter, and ice. Substances have high melting point like iron, copper, aluminum or aluminium, and table salt. Okay. What the meaning of low melting point? What the meaning of high melting point? Okay. Does the ice melt at the same temperature that the iron melts in? I think they have different melting points. So we separated them into groups. One have low melting point and the other one have high melting point. Now let's talk about some life applications for melting point. One, manufacturers, or we can say workmen. You can say manufacturers or workmen. Workmen melt metals. Why do they melt metals? To be easy for them, to mix them and shape them again to form alloys. Like what? Such as the copper gold alloy that is used in making jewels, and the nickel chrome alloy that is used in making heating coils. So to make heating coils or jewels, we need to go through the process of melting. The next type of application for melting process is cooking pots. Cooking pots are made up of aluminium or stainless steel. Why? Due to their high melting point. When you think about it, if aluminum or stainless steel have low melting point, if remember, I'm saying if aluminum or stainless steel have low melting point. In this case, you will have your food filled with aluminum, and no one wants this, right? So, aluminum and stainless steel have a high melting point. So, we use them in making cooking pots. So, cooking pots are made of aluminum or stainless steel. And remember, I said you can say aluminum or aluminium. The next way to differentiate between different matter is boiling point or boiling process. Boiling process is the change of matter from liquid into gas By what? By heating. So remember, we need heat to change matter from solid to liquid, and we need heat to change matter from liquid to gas. Let's move to boiling point. Boiling point is the temperature at which matter begins to change from liquid state into gas one. Now let's talk a little about life applications of boiling process. Separation of components of petroleum oil, or we can say crude oil. Okay, so we can separate components of petroleum oil or crude oil through boiling process. How does this happen? Okay, the components of petroleum or crude oil, each one of them has a specific boiling point. So each component will become gas at a specific temperature. So each one of the components of petroleum oil or crude oil has a specific boiling point. At this boiling point, at this temperature, this component will become into gas. We've talked about some physical characteristics like color, taste, smell, density, melting point, and boiling point. I think it's time to talk a little about hardness. Now let's talk about hardness. Okay, when you hear the word hard, what is the first things that come into your head? Solid, liquid, gas? Of course, solid. Solid substances, we have a variety of solid substances. So how can we differentiate between them? We can differentiate between solid substances by dividing them into three types according to their hardness. The first one, soft solid, like a rubber. Two, solids that become soft by heat, as metals. 3. Solids that can't be softened, as coal. Now let's talk about some life applications of hardness. The first one, screwdriver. Screwdriver is made up of steel iron. Why? Because it's very hard. The second one is the rods used in building concrete houses are made up of iron, not copper. Why? Because the hardness of iron is more than the hardness of copper. You may ask yourself, why do we use iron instead of copper? We need strong houses, so we will use iron instead of copper. Why? Because the hardness of iron is more than the hardness of copper. Now we've talked about color, taste, and smell, but remember, we're still in the physical characteristics. We haven't moved yet to chemical characteristics. So we talked about color, taste, smell, density, melting point, boiling point, and hardness. Now it's time to talk about electric conductivity and thermal conductivity. Let's start by electric conduction. We have two types, good conductors of electricity and bad conductors of electricity. The first one, good conductors of electricity, are substances that allow electricity to flow through. Examples like metals, iron, silver, copper, aluminum, some solutions as acidic solution, alkaline solution, and some salt solution. On the other hand, we have bad conductors of electricity. These are substances that don't allow electricity to flow through. Examples like gases, some solid substances as sulfur, phosphorus, wood, plastic, some solutions as solution of hydrogen chloride in benzene, and sugary solution. So again, we have in solutions, specifically in solutions, we have solutions that are good conductors and others are bad conductors. Good conductors like acidic solution and alkaline solution and salt solution. Bad conductors like solution of hydrogen chloride in benzene and sugary solution. Now look at these two electric circuits. Of course you can observe that the one with insulating ceramics don't allow electricity to pass through. while the one with metal allow electricity to pass through. So you can observe that ceramics, wood, and etc. are bad conductors of electricity, while metals and etc. are good conductors of electricity. Now let's talk about some life applications of electrical conduction. Electrical wires are made up of copper or aluminum and covered with plastic layer. Okay, you may ask yourself why we make them from copper or aluminum and cover them with plastic layer. Why? Because both copper and aluminum are good conductors of electricity, while plastic is a bad conductor of electricity. So when you hold that electric wire, you don't get shock. So we use copper or aluminum to make electric wires, and we cover them with plastic layer, and we cover them with plastic layer. Another life application of electrical conduction is electric screwdriver. Electric screwdrivers are made up of steel iron, while their handles are made up of wood or plastic. Why? Because steel iron is a good conductor of electricity, but wood or plastic are bad conductors of electricity. And for the same purpose, when you use screwdriver, you don't get shocked. Now I think it's time to talk about thermal conduction. We have good conductors of heat and bad conductors of heat. Good conductors of heat are substances that allow heat to flow through, like metals, iron, silver, copper, aluminum, and etc. And we have bad conductors of heat, like non-metals such as wood and plastic. Bad conductors are substances that don't allow heat to flow through. So substances that allow heat to flow through are good conductors of heat, while bad conductors of heat, substances that don't allow any heat to flow through. Some life applications of thermal conduction. Cooking pans are made of aluminum. Why? Because aluminum is a good conductor of heat and it has high melting point. So we have 2 points to consider. The first one, aluminum is a good conductor of heat. The next one is aluminum has a high melting point. Aluminum is a good conductor of heat. Aluminum has a high melting point. Another life application of thermal conduction is handles of cooking pans are made up of wood or plastic. Why? Because wood and plastic are bad conductors of heat. So, when you hold the pans, you will not feel the heat. Now, after we've talked about physical characteristics like color, taste, smell, density, melting point, boiling point, hardness, electric conductivity, and thermal conductivity, I think it's time to talk a little about chemical characteristics like very active materials, less active materials, and inactive materials. Let's start by very active metals. Very active metals like sodium and potassium. Okay, how are they reactive? They react with water and air very fast, like as you can see in these videos. Okay, how can we keep them? We can keep sodium and potassium under kerosene surface to prevent the reaction with atmospheric oxygen. So how can we keep sodium and potassium and prevent them from reacting with atmospheric oxygen? By putting them under kerosene surface. Now let's move to less active metals. Less active metals like iron, aluminum, and copper. Okay, how are they less active metals? They are less active metals as they take time to rust. Like iron, if you put iron in the air, it will not rust as this time immediately. No, it will take time. It will take time to rust. So we say that iron, aluminum, and copper are less active metals. They take time to react. Some life application of chemical activity. 1. Steel bridges and holders of light bulbs are painted from time to time. Why? And the metallic spare parts of cars are covered with grease. Why? to protect them from rust and corrosion. So steel bridges and holders of light bulbs are painted from time to time. Metallic spare parts of cars are covered with grease. Why? To protect them from rust and corrosion. To protect them from rust and corrosion. At last we have inactive metals. Inactive metals that don't react, like silver, platinum, nickel, gold, and chrome. They don't rust, so they are inactive metals. Some life applications of chemical activity. Silver, gold, and platinum are used in making jewels. Why? Because they are chemically poor active, so they keep their luster for a long time. And luster mean shiny. So silver, gold, and platinum are used in making jewels because they are chemically poor active, so they keep their luster for a long time. Another application of chemical activity. Nickel, gold, silver are used to cover other substances which rapidly gain rust, such as iron. Why? To protect them from rust and corrosion.